Hello everyone, myself deepak.d. I am an assistant professor in the Department of Computer Science and Engineering at Canara Engineering College. So we will be discussing Module 2 of Operating System. So in this module, we shall see three major topics. One is with respect to multi-threaded programming, and another is process scheduling, and the last topic is with respect to process synchronization. So in this chapter, that is multi-threaded programming, again we shall cover four major topics. One is what are the fundamental concepts which underlies in the threading, and another is multi-threading models, thread libraries, and threading issues. Let's start a very basic concept with the thread. What do you mean by thread? A thread is a very basic concept of CPU utilization. What actually that thread consists of? It consists of basic components like a thread ID, program counter, register set, and the stack. You can see here the pictures. One is single threaded process and multi-threaded process. Here, when you have a multi-threaded process, there are some components which can be shared with other threads. Condition is it has to belongs to the same process. Those are, one is code section, another is your data section, and the file section like other operating system resources like files and all, such as opening a files and signals. So these are the three components which can be shareable by the multiple threads, and for each and every individual there are two components which are identical for each thread. One is registered and another is stack. So here a traditional process, or what we can call it as, sometimes called as heavyweight process, which has only one thread. See in this diagram, which consists of a single thread, means a process has a single thread of control. But whereas here, if a process, assume that this is a process which consists of a multiple threads, means there is a multiple thread of controls where it can perform multiple tasks at a time. So this is the major difference when you have a single thread and multiple threaded process. That is, code, data and files can be shared among the threads. Those threads should belong to the same process. Let's see the motivations and the concern behind this multi-threaded programming. The main thing is, nowadays whatever the softwares you people are using that are running on, or that will run on the modern personal computers which are multi-threaded. See, nowadays whatever the applications you have or you are using, which is mainly implemented as a separate process which is having the multiple threads of controls. So let's take an example here. The example is a web browser. Assume that you are using a browser. Whenever you open a particular website, so that web browsers having multiple threads which will be handling some of the tasks like displaying the images and getting the text, and while another threads might be used for retrieving the data from the networks. This is one example. Another example, let's see that word process that we use on daily basis. That word process can have or will have the multiple threads which is used, or some of the threads are used for displaying the graphics, and another threads or another thread might be used for responding to the keystrokes from the users, and another thread might be used for performing spelling and grammar checking in the background. So these are some of the examples with respect to the applications which is having the multiple threads. So there are some situations where a single applications might be required to perform several similar tasks. For example, you have a web servers. Assume that web server accepts a client request for performing some of the requests like getting the web pages or images or sounds and so on. So assume that your web server is busy right now. So that web server might have several clients which wants the data to be accessed concurrently. So if that web server is an traditional single threaded process, assume that. So what it happens? It would able to serve only one request per time, or one request at a time for a particular client, and all other clients has to wait for a longer time for its request to be served. So in order to overcome these situations, there are multiple solutions are there. One of the solution is you have a server which runs as a single process that accepts a request. So when server receives request from the clients, it creates a separate process. That process is used to serve the request which is taken from the client. So here what happens here, there is little bit time consuming with respect to the process creations, and also the resources which need to be allocated for the process. So here the two major drawback, one is the time consuming and another is resource. It has to be allotted. Sometimes that entire resource might not be used for 100%. So these are the two major drawbacks of this process creations. So hence another solution is, instead of creating a process, better you create a threads for serving the request for a clients. So assume that if the web server process is multi-threaded, so that server will create a separate thread that listens for client's request. So whenever the request is made by the client, you can see this in the diagram. So whenever the clients make a request to the server, what the server will do? Server will create a new thread to service the request. So the thread is created now. So if assume that another client may also request for a service to the server, what it does, again new thread is created. Means when a request is made, rather than creating a separate process, the server will create an additional or new thread to service the request and resume listening for an additional request. So I hope this diagram is clear for you people. So hence we call it as process creation is a heavy weighted, because it is time consuming and resource need to be allocated. But whereas thread, it is called as light weighted. So this is, you have understood. The next one is, nowadays whatever the operating systems kernels are there, those are all multi-threaded kernels. So multi-threaded in the sense, there are several threads which operates in the kernel, where each and every thread performs a specific task. Some of the examples are like managing your devices. Sometimes it might be used for managing the interrupts, means interrupt handlings. So these are all the things that will be done by the kernels with the multi-threading concepts. Let's see the benefits of multi-threaded programming. These are majorly divided into 4 categories here. One is the responsiveness, resource sharing, economy, and scalability. Let's see the first one. What is that responsiveness? Assume that you are using an application which is an interactive in nature and it is multi-threaded. So that application will allow a program to continue running even if some of the parts might be blocked, or it might be used, or it may be performing some of the lengthier operation, but still it will increases responsiveness to the user. Some of the example, like your web browser, as I said that it is a multi-threaded web browser that will allow user interaction in one thread, and another thread might be used to load the images. So this is one of the example for your responsiveness. Second one is What do you mean by resource sharing? See, process may only share the resources by using some of the techniques. As we already seen that those techniques such as shared memory or message passing systems. So these techniques must be explicitly arranged by the programmers. But when it comes for the threads shares the memory and the resource of that process to which they belongs to by default. So this is the concept behind the resource sharing with respect to the threads. So what is the benefit of sharing the code and data? So that will allows an application to have several different threads of activity within the same address space. So the next one is economy. So allocating the memory and the resources for a process creation is costlier, that you know that. But when it comes for the threads shares the resources of the process to which they belongs and which is more economical to create and context switch between the threads. So this is the third one. The fourth one is scalability. See, let's see the benefits of multithreading. See, that the benefits of multithreading can be increased in multiprocessor architecture where threads may be running in a parallel on different process. Assume that you have a single threaded process that can run only on one processor regardless how many are available. But in multithreading on a multiple CPU machines increases parallelism. So these are some of the benefits of your multi-threaded program. The next concept is a multicore programming. Nowadays you might have heard about a system which is having the multiple cores like dual core, octa-core or quadra-core. So these are the systems which are designed in such a way that these multiple computing cores are placed in a single chips. So whereas each core will appear as a separate processor to the operating system. So what is the advantage of a multi-threaded programming? So this multi-threaded programming provides a mechanism for more efficient use of these multiple cores and also improves the concurrency. So let's take an example here with respect to the concurrent execution on a single core system. So assume that you are having an application with the 4 threads. So on a system with a single computing core, okay, what we call it as a concurrency, which is mainly that it means that the execution of the threads will be interleaved over a time with respect to the single core. As remember that the processing core which is able to execute only one thread at a time. So here you can see that after completion of the T1, the next one is the T2, T3, T4. The next again it continues like T1, T2, T3 and T4. Concurrency in the sense which are interleaved over a time. Okay. The next one is the parallel execution on a multi-core system. Assume that you have 2 cores, core 1 and core 2, and you want to run an application which is having the 4 threads. So you can see here. So thread 1 is running on core 1 and thread 2 which is running on core 2. Similarly, with respect to T3 which is on core 1 and T4 which is on core 2. Means on a system with multiple cores, concurrency means that the threads can run in parallel. So as a system can assign a separate threads to the each of these cores. So I hope this is you have understood clearly what do you mean by single thread and multi-core with respect to the multi-threaded programming. So you have seen a system which is having a single core and a system which is having the multiple core. So in the single core, when we talk the concurrency means it is like interleave, means that threads are interleaved over a time. But when it comes for the multiple cores, you are actually assigning the multiple threads to work parallelly. So this is with respect to the single core and multiple core. Means the execution of these threads on a single core may take longer time than your multiple core. So let's see some of the challenges that where we as a programmer face with respect to the multi-core system. One is dividing the activities. What it means? See, before making the system to execute this application or any of the application, you have to examine your application to find the areas where that can be divided into separate and concurrent tasks, and that can run in a parallel on an individual course. This is with respect to the first one. Second one is not only identifying the task, but also you have to ensure that the task perform equal work of equal value, which means that assume that there is a task which may not contribute as much as with respect to the overall process of the other task. So using a separate execution code to run that particular task may not be worth. So you have understood that one. Balancing. So the next one is data splitting. Just you have seen that data dividing the activities and balancing. As an application, that applications are divided into separate tasks. Not only that, you have to make sure that the data accessed and manipulated by the task must be divided to run on a separate course. So this is with respect to the data splitting. And the fourth one is data dependency. See, the data which is accessed by the task must be examined for dependencies between the two or more tasks. The last one is testing and debugging. See, when the program is running in parallel on a multiple cores, there are many different execution paths. So testing and debugging such concurrent program is inherently which is like more difficult than your testing and debugging a single thread applications. So these are the 5 major challenges with respect to the programming for multi-core systems. Next, see that multi-threading models. See, however, the support for the threads has to be provided either at the user level or at the kernel level. So when we say that a support which are provided by the user level, then we call it as a user threads. Means the threads are managed and which are done by your user level threads library. And some of the major examples for your user threads like your POSIX P thread, Win32 thread and Java threads. So the next one is your kernel thread, in the sense that the support which are or the support provided by the kernels, then we call it as the kernel threads. So user threads are supported above the kernel and are managed without kernel support, whereas kernel threads are supported and managed directly by your operating systems. So some of the examples for your kernel threads are like your Windows XP and Solaris, Linux and so on. So as you know that there are 2 types of threads are there. One is user threads, and those threads are supported at the user level, and another is your kernel thread which are supported by the kernel. So now there should be an relationship that must exist between your user thread and also the kernel threads. So there are 3 commonly ways or common ways of establishing some relationship between these user threads and also the kernel threads. Which are those 3 relationships? One is many to one, one to one, and many to many. So these are the 3 different or 3 common ways of establishing the relationship between the user thread and kernel thread. You can see in this diagram here, when we call it as a many to one, means there are multiple user threads and only one kernel thread. Means so many user level threads which are mapped to the single kernel thread. So what is the advantage of this model is the thread can be, or it means that thread management is done by the thread library in the user space, so it is efficient. Second one is the disadvantages. So there are two disadvantages are there. One is the entire process will block if any one of these threads makes a blocking system call. The second one is multiple threads are unable to run in a parallel on multiprocessor. So these are the advantages and disadvantages of many to one model. And some of the examples are Solaris green threads, and second one is GNU portable threads. The next model is one-to-one model. Here you can see here each and every user threads are mapped to an individual kernel threads. So what is the advantage of having this model? It provides more concurrency by allowing another thread to run when a thread makes a blocking system calls. And second advantage is multiple threads can run in parallel on multiprocessor. But what are the major disadvantages? So creating a user thread requires creating a corresponding kernel threads. So this is the major drawback of this one-to-one model. And some of the examples for this model is Windows NT, XP and 2000, Linux and Solaris 9 and later. The next model is many-to-many. Here you can see in this diagram there are more number of user thread and there are kernel threads which are lesser than your user thread. So here these user level threads are multiplexed to the smaller number of kernel threads. So what are the advantage of this one is developers can create as many user thread as necessary, and the kernel threads can run in parallel on multiprocessors. So when a thread performs a blocking system calls, kernel can schedule another thread for execution. So this is the advantage of having this model. And some of the examples for this model is Solaris prior to version 9 and Windows NT 2000. So the next one is one of the popular variation of your many-to-many model. See, that model is called as a two-level model. What it does, this multiplexes many user level threads to the smaller or equal number of kernel threads, and also allows one user level threads to be bound to the kernel threads. So this variation is called as two-level model, and some of the examples are IRIX, HPUX and also Solaris 8. So thank you so much.